Modern enterprise AI deployment operates under a dangerous assumption that if a model is safe in the lab, it is safe in the wild. Current AI governance tools are highly effective at monitoring behavior inside a controlled environment. Platforms like IBM's watsonx.governance actively track for data drift, hallucination rates, and algorithmic bias while the model is thinking. But that sandbox governance reaches its absolute limit the exact millisecond an AI agent initiates an autonomous, real-world action. In heavily regulated industries, legal liability does not care what an AI predicted in isolation. Liability is generated by the execution. It comes from the specific email sent to a client, the precise database query run, or the financial workflow triggered on behalf of the company. When an auditor steps in, looking at model layer metrics is useless. They ask distinct structural questions. What exactly did this agent do? Who explicitly authorized it to act? And how can you cryptographically prove it? Regulated communications are governed by exact legal frameworks. Real estate agents answer to RESPA, healthcare providers to HIPAA, and financial institutions to SEC Rule 17a-4. Violating these statutes triggers massive institutional penalties. Deploying AI agents without a flawless, verifiable record of their actions exposes the enterprise to unbounded regulatory risk. Solving this requires infrastructure that operates outside the model entirely. It requires an attribution layer that captures every real-world interaction an AI initiates and logs it to a mathematically unalterable record. This diagram illustrates Thread. It is an action layer infrastructure built directly beneath the model governance stack, designed specifically to capture and verify these external events. To guarantee the integrity of these records, Thread is built natively on the Hedera hash graph. This public ledger provides sub-3-second finality and is governed directly by 31 Fortune 500 adjacent institutions, including IBM and Google. True sovereign AI exists only when you combine predictive intelligence with a tamper-proof, ledger-backed cryptographic record of the resulting actions. The architecture of Thread operates across 3 distinct layers. At the foundation is the Spider protocol. Its sole function is to intercept every outbound action an AI agent attempts to make. When an action is intercepted, the protocol extracts specific metadata. It isolates the cryptographic identity of the AI, categorizes the action type, and records the exact human authorization chain that delegated authority to the agent. This structured record is then submitted to the Hedera consensus service. Within 3 seconds, Hedera applies a Byzantine fault-tolerant timestamp, permanently ordering the event in a way that can never be front-run or altered. Writing enterprise data to a public, immutable ledger immediately raises a structural problem. Storing personally identifiable information on a ledger that cannot be erased violates data privacy laws. To solve this, Thread's architecture never writes the actual content of the action to Hedera. Instead, it generates a SHA-256 payload hash, a unique mathematical fingerprint of the data. The sensitive content remains secured in the enterprise's private systems. By logging only the hash, the enterprise retains absolute cryptographic proof that an event occurred exactly as claimed, while preserving the ability to delete the original content from their local servers if a user requests data erasure. Capturing single, isolated events is only the first requirement. Liability in an enterprise environment requires understanding the complex chain of causation over time. This brings us to the web graph layer. Built entirely on Hedera's smart contract service, this layer uses Ethereum virtual machine composability to map the specific relationships between human operators, systems, and active AI agents. The smart contracts draw direct connections, or edges, between these nodes. They map exactly how authority flows from a licensed human principal to an AI agent, and track which specific system the agent queried to execute a task. Because this relationship map is constantly evolving, the state of the smart contracts is periodically snapshotted and checkpointed down into the immutable Hedera consensus service layer. The web graph translates a chaotic stream of raw event logs into a structured, queryable audit trail. It explicitly visualizes the chain of custody for every AI action. A mathematically perfect audit trail is useless if the system is too volatile to scale. Historically, enterprise adoption of public ledgers has been blocked by unpredictable gas fees that make annual budgeting impossible. The final layer of the stack solves this commercial barrier. Vault economics governs system access and capacity, denominated exclusively in Hedera's native token, HBAR. This graph compares network costs over time. Unlike legacy systems that fluctuate with network congestion, Hedera transaction fees are strictly pegged to the US dollar. Every consensus message costs exactly 1/100th of a penny, establishing a fixed baseline. Enterprises access the infrastructure through distinct throughput tiers. Instead of managing complex liquidity requirements, operators simply maintain an automated minimum H-bar reserve in their account to fuel their chosen capacity band. By utilizing Hedera's stable fee structure, Vault Economics converts decentralized ledger technology from a speculative variable into a predictable operating expense. We can see this infrastructure applied directly in the real estate sector through the iRes 360 platform, built for iReal estate solutions. When a single company owns the brokerage, the lender, and the title company, cross-selling services creates extreme regulatory exposure. Improper timing or incorrect language in an affiliated business referral can immediately trigger RESPA and Section 8 violations. To neutralize this risk, iRes 360 employs a locked frame architecture. This design physically separates the strict deterministic requirements of the law from the probabilistic text generation of the AI. The outer frame is hard-coded by the legal department and cannot be overridden. It forces the inclusion of required NMLS identification numbers, mandatory affiliated business arrangement disclosures, and functional opt-out links on every single message. The Watson X AI model is permitted to operate only within the center of this frame. It dynamically adjusts the tone and specific message based on the lead's current stage, but it cannot alter the legal boundaries surrounding it. Every time this email is generated, the Spider protocol intercepts the action. The payload hash is immediately generated and securely logged to the Hedera ledger. The AI is entirely stripped of compliance liability. The probabilistic model is forced to operate strictly inside mathematical, legally enforceable boundaries, backed by an immutable record of every send. Traditionally, updating enterprise compliance policy required drafting new PDFs, pulling thousands of human agents into training seminars, and hoping the new rules were adopted. This inevitably results in compliance drift. A dangerous gap opens between what the legal department approved and what the sales team is actually sending in the field. The iRes 360 system eliminates this gap entirely. A single update to the system's governed prompt instantly aligns the entire organization's communication. By applying a simple tag inside a CRM, an operator can execute thousands of fully compliant actions simultaneously. The language updates automatically, requiring zero retraining and zero human rollout. Corporate AI governance shifts from being an HR training problem into a centralized, highly scalable software deployment. Securing AI at scale requires two entirely different functions working in tandem. Enterprises need platforms like WatsonX.governance to monitor the model's internal logic, and Thread on Hedera to definitively attribute the resulting actions. The institutional trust in this system is anchored by the Hedera Governing Council. Because major enterprise players like IBM co-govern the underlying public ledger, the infrastructure aligns directly with corporate risk management standards. This architecture creates the foundation for true sovereign AI. True sovereignty dictates that the operating institution retains absolute, provable control over every output. The authority rests neither with the software vendor nor with the AI model itself. During an audit, enterprises don't rely on internal logs. They produce a mathematically unassailable sub-3-second consensus record directly from a public ledger. Making autonomous AI actions legally defensible in the real world depends on building the rigorous cryptographic infrastructure required to back every output.